Dear audience. Okay, now it's working. Thank you very much for coming. We are in the second part of our program. Now it goes about rescuing people, how safe you operate, and at least we make also an excursion to the Himalayas with Gerold Piener, and then we will hear also Fabi Riesen from VR Motion on the new age of simulated training in helicopter. Now I would like to give the floor to Stefan Becker from Rega, Swiss Air Rescue. He's a man of many hats. You see him and then he's gone again. So I'm very pleased that he's here today for giving us his take on the low flight network and how this network helps Rega to save more people in bad weather conditions.
Thanks, Philip. So, bye-bye, I'm gone. No. All right. Yeah, ladies and gentlemen, thank you for the opportunity to talk to you today about the Swiss low flight network. The question is, why do we do that? Why are all these efforts necessary? I start with a general compliance slide. There are no conflicts and conflicts of interest. I have to declare the affiliations. You see here, due to the time, I would like to skip that. What you hear are my personal opinions, and I would like to share with you. Well, why do we need a low flight network? Why is that really necessary? Is it? Well, first of all, we talk about Heinz minima. So Heinz flights usually are conducted under VFR, so the VFR minima are applicable. And that is, especially in a high mountainous operation, a demanding environment, also due to the topography. We have approximately 8% aborted or cancelled missions due to weather because the VFR minima cannot be met. And the second aspect, we have cold temperatures. For sure, you know, the higher you go, the more likely it is to get colder. A certainty, not a likeliness. But on likeliness and probabilities, Heinz Wipf will talk later. So we talk about icing conditions. We have also the challenge, can we have a forecast of icing? When you start a mission somewhere, you would like to know if you might encounter or will encounter icing conditions. And that is paramount in terms of safety. The current weather reporting system was also at the beginning not available 24/7 in the necessary valleys we would like to fly, and so we had to improve that as well. The third is the operation environment. You see the beautiful landscape and topography of Switzerland, clear sky above a nice cloud layer and beyond the valleys. So how do we operate here? And all that can be done only in a specific way. VFR, difficult, I would say, isn't it? So that is the impact. We were looking, is it really relevant? Or do we talk about just an academic exercise? And it is not an academic exercise because the impact analysis has shown and proved that, we have approximately 600 patients and missions per year in different locations also that we cannot serve. Especially, you see, not only necessarily in the high mountainous area, but also in the midlands. Well, Switzerland has not really lowlands, but there are midlands here. And that means 600 patients. Rega conducts several more than that, up to 15,000 missions. But we talk about 600 patients and lives and the families that are involved. And we would like to serve them as well, because everybody deserves modern state-of-the-art treatment. So what is the vision? How should we and could we fly in such demanding weather conditions? Well, the problem as stated, visual flight rules are not applicable in instrument meteorological conditions, IMC. You can use only IFR rules. And that brought us to the idea we could create a network in Switzerland, a kind of sky highway with a route from the west to the east, from the south to the north, so we can combine the different parts of Switzerland in a route network. And that would enable us, That would enable us to cross, for instance, also high mountain ranges like the Gotthard Pass, which you find around here, also in bad weather conditions. So if you have a baby, a newborn, that has to be flown from the southern part, Ticino, to the northern and middle part, or also to the western part, where the treatment facilities, specialized tertiary centers are located, we can do that also in bad weather conditions. That was the idea. And in order to have just the sky highway, the route network, that won't help alone. You need also ramps to enter that route network and to get down again to the hospitals and to the bases. And these procedures are point-in-space procedures. So that is the implementation concept. I have only 50 minutes, so it's a bit difficult to go into details at that. But I want to raise and focus on the implementation itself. So what we did the calculation of flight validation of the procedures here, the routes and procedures. We did an extensive risk management. Heinz Wipf will talk about the risk as well today. And Heinz Leibundgut, the founder of the low flight network, will talk about the operational aspects. We have the privilege to have good partners, knowledgeable partners, namely the Swiss Air Force, the Federal Office of Civil Aviation, and also Skyguide, the air navigation service provider. That is important. And we looked into the following aspects. The routes and pins procedures with the design have been set up, the flight inspection and validation, the risk management, legal aspects. Same with ATM and ANSP, radar coverage is an issue. You would say, okay, can you do that without air traffic management? Well, we have not enough secondary radar in all valleys, so at certain parts we operate that without air traffic management, but certainly with a filed flight plan, of course. So if you enter a sector, the sector will be closed for just this one helicopter, and of course you need to follow a flight plan before. You can imagine that is also with considerable legal aspects associated. And the weather, well, mentioned already, because flying an IFR is quite nice, but when it comes to landing, the last segment of these approaches is always a visual segment, and so we need the weather, of course. We looked also at the quality, distribution, also legal aspects, because flight weather has its own definition. So you see the last point everywhere is legal aspects where we had to deal. And I'm happy to say we found solutions with all partners. So how does it look like? What is the strategy here? You see on the left side, the LFN, the low flight network routes, we have different sectors, as you can see. And when you start here, for instance, in Ticino, and you would like to fly to the mainland, this sector will be blocked for the time being. The helicopter is in the sector. So only one helicopter can fly without ATM in the sector. You see here the planned point-in-space procedures, the ramps to and from the low flight network, so that the most important parts are linked. Points of these procedures are tertiary centers, so specialized hospitals according to the highly specialized medicine in Switzerland. There is a list, and that is done by the Health Minister Conference, but also other important infrastructures in Switzerland, because it's not only for Rega, it's not only for the other blue light organizations like also Pfammatter, Glacier, and whoever provides HEMS flights. No, it's also for the Swiss Air Force, because it's a para-public network. And that is important. And I'm happy to say that it has also been acknowledged by the Swiss Parliament. I'll come to that a little bit later. When you look at the concept in brief, we looked at the processes. The priority is given, I said already. Sector usage, I have already informed. There is a communication frequency. The flight plan is mandatory, certainly. You have authorization required. If there is an inactive airspace, blind calls are mandatory from our side, of course, and the regular flight preparation, as you know it. Regarding the aviation infrastructures, similar, they are usually linked with PBN procedures or usually departures with standard instrument departures. VFR minima for all non-directly connected procedures. The recent rulemaking at the EUROPEAN, especially when I look into all-weather operations concept and the new Heinz opinion, even gives more alleviations for these specified procedures, because if you see the heliport in, let's say, 800 meters, why should you need a minima of several thousand meters? You can land safely. That has been taken into account. So that is, at a glance, the ops concept. And as said already, and I'm happy also, National Councillor Martin Candinas, President of the Swiss Helicopter Association, is here. There was a motion in the two chambers of the Swiss Parliament, and the low-flood network, as it has been also proposed and developed by the partners Swiss Air Force, Rega, Skyguard and Fokker, has been adopted with a really tremendous acceptance. The Council of States voted with 41 yes unanimously, and the National Council voted with 182 yes and 2 abstentions. So you see, there was not a single nay. People are convinced this is the right thing, and so the low-flood network will become a national critical infrastructure for the Blue Light Organization in order to provide parapublic important services for the Swiss population in all weather conditions. Almost all, because still a few conditions might remain with winds and so on where it might be challenging. But thank you also politicians for the understanding and support. That gave us important push also. Where are we at the moment? You see here the current situation of the low-flood network. We planned approximately 40 procedures, and you see already helicopters flying around, trying to link the different hospitals with patients. As mentioned, you have the east route, and you have the north-south, and vice versa. You see already here the tertiary hospitals are main hospitals, and then we have also planned links with special interest where we link regions to the Swiss low-flight network in order to provide services for these regions in critical time. So that is what I can say briefly. The outlook is, can we fly anytime, anywhere, in any weather? That's the question, because anytime we fly already, Rega operates its 18 helicopters day and night in Switzerland, usually within 15 minutes from the call to the patient, because we operate throughout Switzerland with the exemption of the canton of Wallis, where we have Pfammatter and Glacier operating in a perfect way. And then anytime, I said already, anywhere, I said already, so any weather. Yes, with a low-flood network, we can operate almost in any weather. One aspect remains, and that is the aspect of icing conditions I mentioned already, and there we need a new helicopter, full de-iced helicopter, and that will be the AW169 FIPS with a full ice protection system, and that gives us then an additional possibility to respond also to the 600 cases that we cannot respond at the moment because icing conditions prevent us from so. New procedures will be implemented, and I'm happy Heinz Leibundgut will inform more about that. We talk about RMP AR.1 procedures, demanding, challenging, interesting, and procedures with enormous opportunities to complete the low-flood network. And then, of course, the outlook will be also near avionics, combined vision systems, including obstacle detection, and so on, so that we increase also safety, not only for the low-flight network, but also in the future, in maybe 5, 10, 15 years, when maybe, and hopefully, and I look always forward to that, we might be able to fly VFR and IMC to provide with electronic glasses, the obstacles, the airspace, as if you could see it through regular glasses, but just electronically with the necessary sensors, and that would be the next step. But first, one step after the other. I think this is the introduction to the low-flight network from my side. I would propose that Heinz Leibundgut will talk more about the details, the operational aspects. He is the father of the low-flight network, and all the questions we are happy to take later on, and Heinz Wipf talks about safety. So maybe if that is fine with the moderator, maybe after the 3 presentations, if there are questions, we would do that, or in the Q&A session as per definition or announcement by the moderator. So that is what I could and would like to tell and share with you. Happy to take later the questions, and thank you for your interest and your attention, and look forward to dialogue with you. Thank you very much, ladies and gentlemen.
Thank you, Stefan. Now I can introduce Heinz Leibundgut. He's a pilot with almost 12,000 hours flight experience, and he has a beautiful story to tell. He has a helicopter that can do things that he is not certified for, and Heinz wants to fly with this helicopter procedures that are not certified yet. At the moment, Heinz likes to tell me that only Santa Claus can fly these procedures. Heinz.
Das ist die letzte Folie.
Sorry.
Das ist vorwärts.
Da ist der Pointer.
Ja, das ist vorwärts.
Das ist vorwärts, genau. Und wenn du zurück bist, ist es da.
Okay, can you hear me? Yes, thank you very much for the introduction, dear ladies and gentlemen. I am pleased and honored to present today, on the occasion of the Swiss Innovation Day, an overview of the ongoing Rega IFR helicopter activities in Switzerland. With your permission, I would like to report on the following helicopter-specific topics that Rega has been working on for more than a decade now. My agenda is as following: a short introduction about the Rega, the HEMS AAAs, Arius project, Arius Insight, and the summary. Rega was founded in 1952 as an association and is now a foundation with 3.6 million supporting patrons. There are 12 Rega helicopter bases are distributed in such a way that the Rega helicopter can provide medical assistance on site within about 10 to 20 minutes. Rega holds the necessary operation license for both helicopter and aircraft, and in order to support the mission has its own flight school, a Part 145 maintenance and a Part 221 design organization. The current fleet of helicopter comprises 7 Airbus H145D2 and 11 Augusta Westland 109s, and for pilot training an H125 Ecureuil. From 2023, the fleet will be strengthened with an additional 3 AW169 Iceberg, as we call the helicopter. The new modern AW169 helicopter will be equipped and certified to allow IFR flights in icing condition and for the RNPAR procedures. All helicopter pilots hold a valid IFR license. Rega's H helicopter crew members are also trained in assisting the pilot in IFR operations and train with the pilots on a regular basis. The Rega 109 full flight simulator in Zurich is now available to the crew for this in-house training task. With the delivery of the 3 Icebird helicopters in 2023, Rega will have also access to the new AW169 full flight simulator at its disposal in the Lufthansa new simulator center at Zurich Airport. The 3 Challenger 650 ambulance aircraft complete the fleet and operated exclusively for air medical missions and are approximately 4,500 hours per year in the air. Since the very beginning, Rega helicopters rescue activities, isolated air rescue missions in the Swiss Alps were also carried out at night. This tradition of flying primary missions to non-pre-surveyed sites at night with rescue helicopters has been steadily improved over the time. Today, all Rega bases are available on 24-hour service. This means that the first A stands for any time. With the provision of more powerful helicopters by the manufacturers, the possibility of carrying out rescue operations in the Alps more safely has also improved. Today, rescue operation can be carried out in good weather conditions, both during day and night, just as the one on the north face of the Eiger with the rescue winch by well-trained crews. Thus, since the mid-70s, the second A has been accomplished, which stands for anywhere. With new technical possibilities, the intention of carrying out rescue flights at any time, anywhere, continues to be realized. But what about the perform rescue mission under any weather condition? Poor visibility is still the most common reason for Rega crew to turn down missions. Even the 600 patients who cannot be flown for weather reasons are entitled to optimal medical care by the air. To be able to help even more people in distress in the future, for many years Rega has been pursuing the vision of all-weather operation for air rescue missions. The gene of continuous improve is the driving force behind Rega's participation in various applied EU research projects to improve helicopter IFR flight procedures. The EU-funded helicopter project aimed to improving emergency medical service, helicopter service, by applying EGNOS, developing and applying procedure that take into account the unique flight dynamic of modern equipped IFR helicopters and access to the GNSS navigation solutions. As the results of this EU project show, operationally sensible approach and departure minimum cannot be realized in topographical difficult terrain, such as in Switzerland, and with the current applicable ICAO PANS OPS design criteria. We collaborate with the Swiss Air Force and Skyguide to develop a network of GNSS-based instrument flight procedures and flight routes, the so-called low flight network, which enable us to perform the rescue missions in almost any weather. The low flight network is designed to be established in practical, efficient and quick connection between all critical landing points for air rescue throughout the Swiss territory. As mentioned before by Stefan, the low flight net and the pins procedure will be future expanded in coming years. The Swiss Parliament has decided by large majority that the low flight network, including the connecting with pins procedure to the central hospital, is of national interest for the medical care of the population and is therefore so financed by the federal government. The following example of a typical topographical situation in the area around the Interlaken Hospital is intended to show where the described problems can be found and how an attempt is made to find a solid solution with the help of various stakeholders. Interlaken Hospital, located between the Lake of Thun and Brienz in the Bernese Highland. The area is well known tourist destination, and the hospital is therefore an important medical infrastructure, especially in winter, when insured winter sport enthusiasts benefit from the service offered by the hospital. As can be seen from the bird's eye view, Interlaken is bordered by mountain ranges to the south and north of the lake. Under such circumstances, the creation of an instrument approach is a demanding task for the procedure designers. In particular, This saves safety distance to the terrain of often hindering the achievement of a low approach minima that is interesting for flight operation. Interlaken Hospital has 3 landing possibilities. One landing site is elevated. During the ski season, it often happens that all 3 landing sites are occupied by rescue helicopters. Particularly in winter half year, however, Interlaken Hospital is below a stratus layer. Above this layer it's good winter weather and below the layer are VFR conditions. I have already explained to you the reason why Rega pursues the AAA strategy, anytime, anywhere and any weather. Allow me to go briefly into the past of Rega's commitment to demonstrate the development of the technical solutions. In 2009, Rega participated in the HEDGE program and, with the support of Steve Hickok, created the first LPV approach in Switzerland. Due to the lack of ICAO LPV criteria, the LPV was created according to then valid FAA. To achieve approach minimum of 347 feet above ground level was exceptional. With the AW109 Da Vinci, several test flights were successfully carried out in the presence of the experts from Leonardo, at this time Augusta Westland, and to the EASA expert. That was 2009. 6 years later, in the following up project, using RMP.3 and radius to fix, a demanding procedure for the flight management system and the 4-ax autopilot was further developed at Interlaken Hospital. In the meantime, the LPV procedure criteria were published by the ICAO and applied to these procedures. Unfortunately, the approach minimum according to the former FAA criteria had to be raised from 347 feet to the new PANSOP criteria and result in a minimum approach of 950 feet above ground level. Even these LPV approach procedures, now adapted to the ICAO rules and provided with the RF flag, could be flown very accurately under VFR condition by the AW109 helicopter with the approved equipment such as the flight management system and the autopilot. Various CESAR projects support the further development of the forward-oriented helicopter-specific IFR procedure using EGNOS. With the PROUD project in particular, we were able to develop a RMP-AR approach and departure procedure at Samaden Airport, tailored to the existing operation capability of the 109 helicopter. As past development have shown, the conventional LPV procedure can only be used to a limit extent under existing topographical conditions. The table gives an overview of the various approach and their minima at Interlaken Hospital as an example. As the comparison between the different approach procedures show, the better approach minimum can be achieved when using RMP-AR procedure. As a result of a various projects have shown useful approach and departure minimum obstacle clearance altitude in the demanding environment can only be achieved with new helicopter instrument flight procedure. Helicopter RMP-AR. So, is it a problem if better approach minimum are achieved with RMP-AR? It's a classic chicken and egg situation. Helicopter RMP-AR and helicopter PINS RMP-AR procedure design criteria do not exist. As no helicopter RMP-AR procedure exists because no criteria are available, OEMs will not produce RMP-AR approved helicopters. Rega wants to change this unfavorable situation by developing the mission specification together with experts in the project ARIOS. The responsible NAA, Swiss Federal Office of Civil Aviation Authority, the air navigation service provider SkyGuide, the OEM Leonardo and EASA have all committed to give the project the necessary support. And I would like to thank our partners, right, for this support and their dedication. Develop procedure criteria for helicopter RMPAR approach procedure. That's the aim of the ARIOS, Advanced Rotor IFR operation in Switzerland. Besides its acceptance of these procedures vital by Swiss Federal Office of Civil Aviation, established of the helicopter RMPAR procedure in Samaden and Interlaken as a test purpose, verification and evaluation of the flight accuracy on the procedure under normal and abnormal condition. The preparation of the required documents as a company operation manual, training manual for the helicopter RMPAR approval. As an example of the ARIOS sub-project, the following is a PINS RMPAR approach and departure for the Interlaken Hospital. The design of the PINS RMPAR process includes the following requirements: the PINS RMPAR criteria, the changing RMP value during the procedure, and includes also the RF leg, radius to fixed leg. The requirement equipment, primarily autopilot and flight management system shall be capable of meeting the specific requirements for accuracy, integrity, continuity, and functionality in both normal and abnormal flight operation conditions. Another challenge is that there are no templates for the procedure charts for helicopter RMPAR. Rega uses its own chart which takes into account the characteristics of the helicopter type used. The PINS RMPAR procedure are located in Gulf and Echo airspace. There is no radar coverage and no radio communication with air navigation service provider. The approach is from the west, includes a radius to fixed legs with a simultaneously descent. The missed approach continues of rising backtrack curve over the Lake of Brienz. The final approach segment has a 5 degrees glide path angle in the point in space. The decision height is 340 feet above ground level, visibility of 1500 meters day and 2000 meters, which corresponds at night, which corresponds to the Rega HEMS night VFR minima. For comprehensive verification, the procedure were flown with 3 helicopters, different types, the AW 189, 169 and 109. Using the examples of the RMP PINS 01 approach and departure at Hospital Interlaken, the advantage of helicopter-specific procedure can be clearly demonstrated. For the verification of the total system error, composed of the sum of navigation system error, the path deviation error, and the flight technical error, we used the flight recording evaluated by Skyguide expert. The GNSS signal recording was done with a mobile GNSS multi-constellation Javad receiver independent of the onboard system. I am pleased to present the first result on the deviation flight based on the example of the Hospital Interlaken. As reported, we have flown this test with 3 different types of helicopter. I have listed the respective total system error results of the flight paths together on this page. Here you can also see that the blue lines predominate in all 3 helicopters, which corresponds to the total system error of less than 10 meters. The deviation in the missed approach climb curve is colored turquoise and corresponds to the total system error of less than 20 meters. The line with a total system error smaller than 40 meters are colored in green. The PIN's RMPAR departure from the hospital landing location Interlaken has been established with a navigation performance of 0.2 nautical miles. This means the helicopter takeoff from the hospital on the VFR up to the instrument departure fix and cross the EDF within 10 degrees of the following RMPAR 0.2 departure track. After passing and climbed the waypoint Hotel Kilo 702, the RMPAR value changed from 0.2 nautical miles to 0.3 nautical miles. The PIN's RMPAR departure connect at Lima Sierra 405 connects to the National Helicopter Low Flight Network. I have listed the respective total system error of the flight paths together on this page. Here you can also see that the blue lines predominate in all 3 helicopters, which corresponds to total system error of 10 meters. I take the liberty of summarizing the finding and evidence from previous REGA activities regarding the helicopter-specific IFR procedure. The available IFR helicopters equipped with digital autopilot, a state-of-the-art flight management system, can already fulfill the requirements for RMPAR operation under normal operation conditions. We have seen that ECNOS increased the availability of the procedure, and based on the SkyGuide random recording data, the failure to the radio frequency interference probability is less than 10 to the minus 7. The probability of a GNS navigation failure, the estimate of the duration of a GNS failure, the topographical environment where the RMPAR procedure is located, and the relevant direction of change within the RMPAR procedure should determine which equipment is required to maintain the necessary navigation performance in the rare cases of a signal lost. The availability of GNSS multi-constellation and multi-frequency receiver for aviation is to be accelerated by the OEMs. Lack of ICAO instruments procedure and EASA C/A certification criteria for helicopter RMPAR procedure will certainly help to develop this kind of new operation. Thank you very much for your attention.
Thank you very much, Heinz. We will come to the last presentation, to these 3 interconnected presentations. It's Heinz Wipf. Heinz Wipf, former air navigation services engineer at SkyGuide. He's in our aviation community in Switzerland, he's our go-to guy when we have issues with the administration when it comes to numbers. When the administration tells us, based on numbers, something is not okay, we bring Heinz in, and Heinz tells the administration, you cannot calculate. And then the problem is solved. Heinz, you have the floor. Thank you.
Kannst du mir noch eine Präsentation da irgendwie vorkützeln? Good afternoon, and thank you, Philip, for the introduction. Can you hear me? I guess so, huh? It's good. I have the pleasure to round up these efforts that have been presented by REGA with some of the more general considerations. And I think the 3 of us will also afterwards be quickly there to answer questions. Now, the title of the presentation is the target level of safety, and that turns out, for practical reasons, in the sense that how safe are you to fly. So the outline of my presentation will include a short problem statement, and the second most important thing that we normally discuss when it goes general is who are the risk bearers. And then I give a short introduction into the target level of safety. There will be an example and a brief summary. So the problem statement, as you have heard before, is that if you do true innovation, normally the rule making will not be there. And so you have to find ways to show that whatever you do in your flight operation is safe enough and commensurately safe with your target level of safety. So the situation, as has been outlined by the two speakers before me, came all up when we introduced the performance-based navigation of ICAO in Switzerland, and one of the projects in the whole program was the sort of low flight nets which has been masterminded by Heinz Leibundgut, as he said 10 years ago. And so we ventured into these performance-based navigations, and there were, of course, these procedures with using new technologies like, for example, GNSS-based procedures. Then the risk, who are the risk bearers? Because everybody does some sort of risk management, and that's probably wrong, because the true risk bearer is the flight operator. And why is that? Because the flight operator is the one that has a risk, that has a loss function, and he also has a probability that he is losing something. All the others of the three constitutive elements in air transportation, like for example airports or the air navigation service provider, most of the time don't have a loss in safety in safety terms, so they cannot risk manage anything. So basically it's the air operator that has the task to do the risk management. So then, of course, when you have the loss function, and in our considerations that was an accident with the aerial vehicle, and then, of course, it is important that you have an estimate on the probability, because otherwise you can't do a proper risk assessment. So the question is, whenever you do this sort of flight operations, which Heinz Leibundgut just outlined before, the question comes up, is this operation sufficiently safe, and is it inside of what you would do otherwise? The methods to do that are well known and also published from ICAO, from EASA, and that is one of the interesting things I see when I do consulting. Normally the flight operation should be risk-based. That has been just mentioned before. Whenever I come together with some clients, I see that they don't do risk-based, they do rule-based. So that is pretty interesting that we should do something like that, but normally we do otherwise. So let me quickly lay out the risk bearers, and that comes after Perot, which is well known. It has been published in 1999. That's also some 20 years ago, if you want. And you see that he says something about the first, second, third, and even the fourth party risk taker, which is not so relevant for us. But we mainly concentrate on that first party risk takers, and those are persons with explicit control of responsibility, as well as other workers who are on site. So that normally is the flight crew, or is the crew in general on board an aerial vehicle. And of course it's also clear, because it's their daily work, it's also clear that they basically bear most of the risk in whatever we do in aviation. Second comes the passengers, but the passengers also have some choice, because they board an aircraft or they buy an air ticket. It's a little bit different if it comes to HEMS operations, but I think we don't have to argue the case if you lay on a glacier with a broken leg, I think we don't have to argue the case whether you can make some decisions as an air passenger. And then it's the third party, and those are persons that haven't got anything to do with aviation, but they are impacted by an accident in the air, and then that is basically a point where some authority, some state authority should have an eye on. But I think in that environment here, we would like that the persons that are knowledgeable enough, they make their own assessment of what they are doing. So then we come to this notion of the target level of safety, this TLS, and the first thing that always pops up is how do we want to measure? Because if we can't measure, goes the saying, we can't manage. So we have to have an idea of how this target level of safety, we get the grips on it. So normally it is not that difficult because most of all the air operators have an occurrence reporting system implemented. That's also not only a recommendation by today, but I think it's mandatory to do it. So basically they have the number of missions they do, they have the number of occurrences they do, and now you have three possibilities to go about. You can attach an estimate, an empirical estimate by the division of the occurrences by the number of missions you have flown. Now in HEMS it's pretty standard because the mission time is something like half an hour or maybe 40 minutes. So you can do it pretty easily if you do the same missions by getting a hold on this probability here. The other way you could do it is that you count the movements. That's up to you. It's a decision that normally the flight operator can take. And the third number, which is the most important one when it comes to different operations, is that you have an idea about the total flight hours that you have flown and how much occurrences happened during that flight hour. And that is normally given by this Greek letter lambda here. And please keep in mind that the unit, while here you have no units because you just have the probabilities, the unit here is something per flight hour. And that you should keep that in mind. Whatever you do, however you define your target level of safety, you have to be proper by assigning the numbers here. Now, when we started some 10 years ago, it was of course a big discussion how large should that target level of safety be when it comes to the Rega flight, to the Rega helicopter, the HEMS flight operation with Rega. So we delved a little bit into the literature, and here you see a couple of these accident rates and the target level of safeties which we derive from them. So here you see this lambda for the flight hours, and you see different flight operators that are displayed here. But so this is all helicopter operations up here, and down here for comparison you see the airline operation. So that was one of the most important statements that we have to make. Obviously there is not one target level of safety that fits all air operations, because the air operations, especially in the helicopter domain, are extremely varied. So every type of mission has probably a different target level of safety, and it is the task of the air operator to find out under what target level of safety he is operating. And then I come to my second last slide. The question then for somebody like Heinz Leibundgut, who is responsible for all the HEMS helicopter operation at Rega, the question is a little bit how, if I am the responsible person, how do I go about with the target level of safety? So in some of the coffee breaks or night sessions, we developed this sort of chart. That is a sequential test. And you see this sequential test has two lines, a red one and a green one. So the difference between the two lines is the factor of 10. And you see here that every time you had an incident that you consider noteworthy, that you go one step up. So basically down here you have the time of your operation or your flight hours, and every time you have an occurrence that you consider noteworthy, there you increase one step. And then you can see whenever you cross the red line here, then obviously you as a responsible person should take some action, because the curve could step up something like that, it could step down something like there, and so on and so forth. And here you see how this is managed day by day. So you don't have to wait until the end of the year to make your statistics, but the person that is in charge can immediately say anytime what is his operation and how good he is following the target level of safety in operation that he has agreed with his company and with his pilot staff. So that's an example that we have applied within Rega to manage this target level of safety. So let me come to the summary. So first of all, what I said, the prime risk bearer is the aircraft operator, and everybody else should manage probabilities, and they should also tell the probabilities they have to the air operator so he can make a proper risk assessment in the sense, should I fly into this airspace, should I land on this airport, and so on and so forth. So he should make the decisions whether it's commensurate with his risks, and he is the only one that should do a proper risk management. So, and the aircraft operator, as I said initially, is forced to make this sort of risk-based approach with the safety management. And I just elaborated on that part here. And when you say, how can we estimate the risks or the probabilities and the severities, that is all pretty well outlined by many organizations. And of course, the risks the air operator is taking should be, as I said, somehow commensurate with this target level of safety which he managed. And the important point is also that there is an acceptable, the risk has to be acceptable within the organization. So that is the end of my presentation. Thanks for your attention, and I hand back to Philip.
Yeah, dear audience, now you have 3 experts on any time, anywhere, under any condition. Have you any question? Please raise your hands. Now it's your chance. Don't be shy. They're all too shy for you guys. Too technical, no? Look, the federal office.
Maybe a short follow-up question. Could you please detail a bit more what you meant under the fact that there are different targets level of safety for every operator?
Yeah, thank you for the question. So because the air operations are so varied, it's almost understandable to anyone that there cannot be the same target level of safety. And why is this also theoretically not so? It is pretty easy to explain, because normally the risk you are taking in monetary terms, like in euros, is the loss multiplied by the likelihood or the probability that you incur that loss on your organization. So it is obvious that an airliner who flies an A320 with 150 passengers has another loss function to a helicopter that has maybe a crew of 4 or 5. So also the value of the aircraft is different. So there is a different loss function. To have the same risk, we can agree on the same risk. In euros, to have the same risk, obviously the helicopter operator can have a larger probability of an accident than an airliner. And it can be pretty easily calculated. We did that, and it turns out that in the respect of the reg operation, it's about the same amount of money that Swiss takes with an A320. Okay, so if we agree, we can agree on the same risk, but that is not the question that a regulator should take, because that's a business question, and it's an insurer question, okay? How much money do you want to lose with what probability? That is basically a question that the operator and the insurance should solve, and not a regulator authority. When it comes to third-party risk takers, we can again discuss, because a person that hasn't got anything to do with aviation and an aircraft crashes on his roof, well, here the state has to do something about it, because that person cannot do anything against it. So if you fly over urban areas, we have to consider something. Well, the HEMS mission are mostly in rural areas, so it's not going to be a problem anyway, because you don't hit inhabitant places or you don't hit citizens by falling debris of an aircraft. But when it comes to urban area, we have to get a second thought on this.
May I add, just from the operational perspective, one aspect. Usually when you look at the operation of airliners, you have different also models, because if you take off and land at a very well established and regulated aviation infrastructure, the likelihood of having an incident or accident is totally different. Also the consequences of a mishap are different, because a lot of precautions have been already implemented in this infrastructure. That is one thing. So as per the definition of HEMS, flying in not pre-surveyed sites, as Heinz Leibundgut has already mentioned also, that means the inherent risk is per se greater. But it is also accepted to be greater, because we need the service. Then the aspect very well mentioned by Heinz Wipf is you have to look at the same aspects. What are you measuring? Because when you measure flight hours or accident-free flight hours, we have no chance ever to compete a long-haul operator like Swiss International Airlines when they fly with their 777 from Zurich into Los Angeles or wherever they fly, because they have one takeoff, one landing, and then they have 12 flight hours. When we have 12 flight hours, you can multiply that by 6. So we have 72 takeoff and landings. You see already, and that is also something we have analyzed in the European helicopter safety team when we did the analysis of accident and incident that happened within 10 years period. So I'm happy also to discuss and elaborate that in a dialogue with you, how we could and should look at that. And that is the reason why there are, for good reasons, different target levels of safety we have to apply.
Thank you, Stefan. And now I would like to welcome Gerold Biener. Gerold. Gerold, he's looking around. He's coming. Gerold is the lucky guy who gets paid for what he loves to do, flying.
Ich habe keine Ahnung.
Oh.
Kopfhörer habe ich nicht.
Genau. Jawohl. He has an experience of more than 14,000 flight hours and he's talking about the Himalayan now. Aber kommt das nicht auf die Präsentation?
Ist gut.
Ist gut.
Hast du das, einen Tricker, wo ich weitergehen kann?
Jawohl. Da immer auf Grün. Kannst du weiter tricksen?
Ist grün. Gut. Okay.
Auf Grün tricksen.
Hello everybody. Can you hear me? Yeah. It's good.
Yeah.
Okay. Thanks for the opportunity. I will try to make it short, not to cut too much of time of Fabi, because that's most probably more interesting than this presentation. Well, let me talk about Air Zermatt, heli skiing in India, what we do there, the helicopter training study group, Nepal, why and how, the exchange of experience, what we did, what we implemented in our MOU, the mountain rating. Switzerland is the only country with an extension in the license. And last but not least, I would like to give this information that there is soon a book which was missing for a long, long time about mountain flying. This trailer, I guess we can skip. Most of the people they know, save some time. Air Zermatt, we are located on the Matterhorn or near the Matterhorn. 20% of our activities, 6,000 flight hours, are commercial air transport. I don't know what commercial air transport really has to do with a sightseeing flight, but anyhow. 60% of our activities, we do about 100,000 slingload operations, up to 4,000 meters. This is construction work. And 20% of our activities remain for rescue missions on two bases. We perform about 1,800 rescue missions a year. We have all kinds of different rescue missions, as you can see. We also have disaster response, and there we are lucky to be an operator who is not only a pure HEMS operator, but as we are operating on a commercial side, we have more access to different helicopters. So in case of a real big disaster, we can employ up to 10 helicopters in one incident or in one major event. So talking about the Himalayas, why Himalayas? It started very early, our experience in the Himalayas. We started in 1990 out of the Manali base, an operation which is now running since more than 25 years, 30 years actually. And this operation in the Indian Himalayas gave us the possibility to fine-tune our training, to fine-tune our skills on high-altitude flying. You see, of course, heli skiing is not liked by everyone, but for us it's a perfect training. Perfect training means whenever you have to fly under conditions like this has not much to do with helicopter flying, but just to tell you, we can combine this fun, and for us it's a perfect education also for young pilots. And whenever we see that pilots come back and they have done like landings up at 5,000 meters, confidence is high, and they have now the abilities that we can use them for HEMS pilot in very high altitudes. So that was since 1990, where we operate the base in the Indian Himalayas. The FOCA, the Swiss Federal Office of Civil Aviation, then came up with a helicopter training study group, where Heinz was also a member, where Monsieur Vichard, who's just next door, he was working at the FOCA, and he tried to get experts from the industry to set up levels. There also, we brought in our experience from the high mountain landings, and this is, for example, what we developed with this helicopter training study group. That was everything related to external cargo sling and human cargo sling. What EASA is producing now, what we have to adopt in all our countries, this is the version Super Light, who came out of this helicopter study group. Same goes for night flying since 1990. In Switzerland, we are performing ANVIS operations, and only now EASA comes out with some new regulations. And yeah, you have to ask, why are there not more experts behind this rule-making task, these rule-making groups, who make it a little bit more easier? Now to come to the last point, Nepal. Why did we go to Nepal? We were asked in 2005, there was an incident on Nanga Parbat. Actually, it was not in Nepal, it was in Pakistan, where a very famous climber, Tomasz Humar, Slovenian climber, was stuck in the famous Rupal phase in 6,000 meters. And out of our connections from the International Commission for Alpine Rescue, we were asked to perform this rescue mission. They asked, you are doing heli-ski in India, can you not just take the helicopter, go into Pakistan and save Tomasz Humar from this hole? There was a political issue, and the Pakistani government, they were not keen to let us go with our helicopter. We had NATO involved, and finally the Pakistani pilots, they did that on their own because they were proud, and they said, no, we won't let foreign crews performing this rescue mission. So they did it. But you can see they used not the perfect material. They used the bungee ropes, regular climbing ropes. They had no communication. And I won't show you the film, but on YouTube you can see the film where during the rescue mission, Tomasz got stuck on the cable, so he was hanging on the helicopter, and his safety rope was still attached in the hole, and they pulled, and he was going up like a bungee jumper and hit his head on the skids of the rotor. Finally, they could save him, and we met Tomasz in Kranjska Gora 2 years later, where he went off, and Tomasz got stuck 2009 again. So the whole procedure started again. They asked us again, can you do this rescue mission? And at that time, we were looking at the B3 for this rescue mission at 6,000 meters. And unfortunately, this time it was too late. We could not do anything. So until we went to Nepal, 2 days passed, and by the time Tomasz died, and at that stage, we could have said to this crew from Simricare in Nepal, thank you guys, that's it. You have seen, we can perform human external cargo operations. It's not easy, and we should have been able to leave without, proposing anything. And the Nepali pilots, they came with the idea we should do something together. And this is where we made a group together, and we developed a project, and it was based on exchange of experience, because we said Air Zermatt should not go to Nepal and create an own helicopter company, but instead we should exchange experiences. Out of the experience we had in India, we said this is an opportunity for us as well to get trained really in the highest mountain, to fly there and on the other hand, we could train them on human external cargo operations. Situation when we arrived was completely different. Political situation, everything was different. The Maoists, they blocked everything, and we knew it's going to be a hard task. But right when we sent one pilot and one mountain guide the first year, that was in 2010, from the airplane they had to go to Manaslu to do a rescue mission above base camp at Camp 2, 6,400 meters. They immediately went from that rescue mission on to Annapurna to perform a human external cargo mission at 7,000 meters, really at the certification limit of the helicopter. And this was the proof also. This is a typical rescued Spanish climber. You see a lot of toes missing. This guy we met the year later. He was blocked on Annapurna in a plane. He did not recognize us anymore. But 2 weeks later, we had to get him off Everest, and then he knew us again. So that's the way it goes. But you know, these climbers, they're tough guys. First thing they ask when they're back in base camp is a cerveza, a beer. We also did some missions on Dhaulagiri. This is North Col down there, the bottom. This is at 6,000 meters, where during the first ascension of Dhaulagiri, they did landings with the Porter, with the Yeti. Unfortunately, the aircraft crashed. And on this mountain, we also did 6 human external cargo missions. And it was kind of a proof that it is working up to the certification limit of the H125. We had the opportunity to fly also on base camp. And even though we saw that there will be in future a problem because it's too crowded, there are too many people. And when you had to land, you had maybe the order to take down 3. And finally, the doors went open, and all by a sudden, you had the squirrel filled up right to the top. And you could not take off. So having no communication, it was quite a difficult task to tell everybody to go out, and you had quite to scream that they did what you wanted. We also had the opportunity to go into the Valley of Death to really try how high can we go on Everest to perform a rescue mission. With Sabine, we went up to Camp 3, a little bit further down, of course, limiting or respecting the certification limit. But we could go into the Kum, passing Camp 1, and doing some landings at Camp 2. That was 2010. The first landing ever made on Everest on Camp 2 was an Italian 205. Unfortunately, during one approach, they crashed the helicopter, and pieces are still remaining up there. So this gave the Nepali pilots already the confidence that they have the skills then to go at least passing this Khumbu icefall, which is really a death zone, and very difficult to bring down the injured mountaineers or the dead bodies. So there we did this approach. For us it was a really, really high learning effect. So we could fine-tune our skills. And when we came back, that was an evacuation of a body. That's what we did. When we came back, we tried to put together a good program for the guys, for the Nepali guys, to train them on sling load operations first, show them the material they should use, that they have the right communication. And unfortunately, November 7, 2010, they went back. We were not ready yet. We were not finished with the full program. And then deadly accident happened. I won't show you this film. Save some time for you, Fabi. Unfortunately, these 2 gentlemen who were trained by us They were killed in this accident, and of course everybody said, you went too fast. They could not fulfill what you wanted to do within such a short time. So it took us another 6 months to finish that project, and in April 2011, we had at least 1 pilot and 4 mountain guides trained, and we kept on going, and now at that stage we can say the Nepali people, they can perform the rescue missions on their own. Since we left, we have trained 6 pilots, and now to save the time, that was the target. With this exchange of Swiss know-how, of this experience, they are able to perform rescue missions above all base camps in the Himalayas. This was an avalanche on Manaslu. You can see up on the right-hand side, this is North Col. So the full Camp 2 was washed down, and there were at least 30 people stocked, most of them half naked, freezing to death. And you can imagine when you sleep during the night and you are hit by an ice avalanche and you lost all your gear, it's kind of a life-threatening situation. So they could really evacuate a lot of people. Same happened on the ice fall on Everest, where 16 Sherpas died, but nobody was talking about the 8 people who could be saved by human external cargo sling operations brought to Kathmandu, and they survived. All done by Nepali pilots and 1 Kiwi. Nepal has, since 2010, when we were the first time in India, made 9,000 medevacs in 10 years. So that shows that the need is there. Unfortunately, still not organized. 50% of these rescue missions are faked. So people come back from their climb and they say, I do not want to walk down for another week. I guess I have a headache. So they call the helicopter and then they blame the insurance afterwards. 2,900 rescues were for local people. Whenever they bring in stuff into these base camps, they try to go into these remote villages and get ill or sick or injured people back to the hospital, either in Lukla or to Kathmandu. And 40% died after the rescue mission. That means it's a proof that helicopter rescue missions are necessary also in Nepal. We have an increase of 15%, and what is important is that with a good education, more than 180 rescue missions were done above base camp, which were not possible until 2010, I would say, and 90 human external cargo missions. That's the team we developed. These are the 3 pilots out of 6 young guys, and these guys are now the trainer for their new generation of Nepali pilots, hopefully doing in near future, whenever you hear about rescue missions on Amadablam, on Dhaulagiri or wherever, these are the boys who are doing it. So what did we take out of this experience? I mean, we are existing since 50 years. We have an area where we go up to 16,000 feet, and still we could fine-tune, like I said. And out of this, that's the whole tactic for mountain flying we teach our students. Everything is on 1 page. For each phase of the flight, you have to be focused just on 4 points. When you follow these rules, you should be able to avoid an accident. And just recently, because since the 70s, where FOCA has brought out some guidelines for mountain training, nothing has been written. Well, there is in Canada, there is a good school for mountain training, but on the book side, there's not much which is really useful for pilots. And this is something we have, or we are the opinion that EASA is doing a few things very good, but one thing which is very bad is the basic education. The basic education, not only on the theoretical side, but also on the practical side, should be improved. And therefore, we supported Simon Wittinger, it's a Swiss guy. And most of the Swiss companies like Rega, like Helilind, Air Glacier, the experts, they brought in all their inputs, and now we have a book coming out, and it is based on learn and improve, learn from others, don't do the same mistakes, you will not live long enough to make them all yourself, etc. And this book will be published only in German for the moment, but from in the mid next year we will have it in hopefully in English as well. Thank you very much.